Hi everyone, it's me Dr. Sikandar Ali. I am assistant professor at University of Haripur. I am teaching you software construction and development. Today uh, we are taking Java Lab 8. In this lab class today we are going to discuss abstraction in Java. So first of all we need to define what is abstraction. Abstraction is a process of hiding the implementation detail and showing only functionality to the user. If we hide detail of the implementation and only the functionality is shown to the user, so we say this software having or this part having abstraction. So in Java we declare abstract classes and then we extend the class and give the implementation in the subclass. Similarly, we can declare abstract methods as well. One example of abstraction is you usually sending SMS short text messages to your friends. So you only know how to type and how to send the message, but you don't know which protocol it follow, how the message box open, how it delivers, and how it through the message go through different layers of the network. You only know how to write and how to send, so you only know the functionality, but the implementation detail is hide from you. So this phenomena is called abstraction. You don't know how the internal processing about the message delivery happens. Abstraction let you focus on what the object does instead of how it does it. You only know what to do and you don't need to know about how to do it. So what to do is the what it do is the functionality and how it do it is the implementation detail. So if you hide the implementation detail and show only the functionality, so we say this program having abstraction. Ways to achieve abstraction are there are two ways to achieve abstraction in Java. The first one is abstraction through class and the second is abstraction through interfaces. So through interfaces we can achieve 100% abstraction, and through class we have variation from 0 to 100. Now the question is that how to declare abstract classes in Java. So to declare abstract class in Java we need to use abstract keyword. A class which is declared with the abstract keyword is known as an abstract class in Java. It can have both. Abstract class can have both abstract method and non-abstract method. If they have abstract method, so the method will only contain the body and the implementation will be given and the subclass. Abstract class, the point should be noted that abstract class must be extended. We must have a subclass of the abstract class because the abstract class only have the body and the implementation is given in the subclass. It needs to be extended. Abstract class need to be extended and its method needs to be implemented. Some points to be remember: we must declare an abstract class with the abstract keyword. Abstract class can have abstract method or non-abstract method. we must instantiate, we must create instance of an abstract class. We cannot create instance of an abstract class. It can have constructor and static method also. Abstract class can have constructor and static method also. It can have final method as well. If they have the final method, then it will force the subclass not to change the body of the method. So if they have the final method, we cannot change the body of the method in the subclass. These are the rules which we defined in the previous slide. So here we are going to repeat it. An abstract class must be declared with an abstract keyword. It can have abstract or not abstract method. It cannot be instantiated. It can have final method. It can have constructor and static method also. How to declare an abstract class? So we will write abstract as a keyword, class is a keyword, and then we will write the name of the class, and then we will write the body of the class and curly braces. Abstract method in Java. A method which is declared as abstract and doesn't have implementation is known as an abstract method. If some method not have implementation and only have body, then we call this method is an abstract method. Syntax of an abstract method is abstract void print status. Print status is a method, and the print status method have no arguments and no return type, and we declare this method with the keyword abstract. So we say that this method is an abstract method. Let's see an example of abstract class with abstract method. So here we have a class bike, which is an abstract class because we have declared the class with a keyword abstract. Since this class is abstract, so this class not have implementation and it only have the body. Abstract class have one abstract method. The name of the method is run, and they have no return type, as we give the return type white, and this method is declared with a keyword abstract, so this is an abstract method. Since it is an abstract method, so there will be no implementation. So in the abstract class we only give the body of the method, only the definition of the method, and the method not have any implementation. So as we discussed in the previous slide that abstract class will not have any implementation, we will implement the abstract class in the subclass. So class Honda is a subclass which extends the class bike, and again we have the run method which have implementation. In the implementation we are just printing a message running safely. So this abstract method are implemented in the subclass Honda. Now we have main method, and in the main method we are declaring objects. So the creating object method is a bit different here. We will declaring an object with a type of abstract class, but then we will creating an object in the subclass. So the type is the abstract and the object is created in the subclass. We will use both names. The name of the parent class is the name of the subclass, and then we are going to call the method. So the method will be called because this method not have implementation, so they will the only method which have implementation is in the subclass. So we cannot create the instance of the abstract because they not have implementation. So this line object.run will print the message running safely on the screen. So the output of this program is running safely. Let's see a more real world example of the abstract class. Here we have a class shape, and the shape class is an abstract class. They not have any implementation, only the definition of the method draw is given here. So draw is an abstract method, and we are not going to implement this method in the shape class, but instead we will implement this in one of the subclass. Class rectangle is a subclass of the class shape. So here we are extending the shape class through rectangle class, and we have the abstract method implementation here. Draw method are implementing here, and in the implementation we are just showing a message drawing rectangle. We have another subclass circle1 which also extend the shape class, and we are going to implement the method again. Actually we are overriding the method, the abstract method, and here we are showing different message like drawing circle. So we have another class test abstract 1 which have the main method. So if we are going to save this program, so the name of the file will be test abstraction1 dot java. The file name will be test abstraction1 dot java, because only this class have the implementation of the this class have the main method. So now, as a usual practice of the abstract class, we will use the abstract class name, and then we will write the object name. So that's showing that this object is the object of the abstract type. The type of the object is abstract, uh, and then we are creating the object in the subclass circle. So if we call the method s.draw, so it will going to print the message drawing circle, because we only create the instance of the circle class. If we write like that, shape a equal to new rectangle, so then if we call the draw method, so it will call this implementation, since we only create the instance of the circle class. If we look at this example, actually in this example we are going to implement multi-level implementation. So through abstraction we can only implement multi-level implementation. In other method, through as a usual practice in Java, we not have this facility. So through abstraction we can do it. So in the previous example, we implement multiple inheritance through abstraction. So as a normal practice, we cannot implement multiple inheritance in Java. In this example, shape is the abstract class, and its implementation is provided by the rectangle and circle class. So shape is the main class, and they have two subclasses. One is rectangle and one is circle class. Mostly we don't know about the implementation class, which is hidden to the end user, and an object of the implementation class is provided by the factory method. Through factory method, We have a lot of design methods and object oriented design. So one of them is the factory method. Factory method is a method that returns the instance of the class. We will learn about the factory method later. In this example, if you create the instance of rectangle class, draw method of rectangle class will be enough. If we create the instance of rectangle class method will be called, and if we create the instance of a circle class, then the circle class method will be called respectively. This is another example of abstract class in Java. So bank is one of the abstract class, and they have one of the abstract method get rate of interest. Now we have SBI is one of the extended class, one of the subclass which extend the main class bank, and this we are going to implement the get rate of interest method. So here we want to, in the implementation, we want to return 7 as the interest rate. We have another implementation of the abstract method get rate of we have another subclass of the main class bank PNB, which is extended, which extend the bank class, and they have the implementation, and in the implementation we are returning the interest rate is 8. We have another class which contain the main method, and here we are going to create one object bank B. The object is related to SBI subclass. We are declaring the object through the type of the abstract. With B object is a type of abstract, and we are creating the instance of SBI. So if we call some method get rate of interest, so it will return 7. We are creating another instance, and if we call, so it will return 8. So this program will show the output look like that. So actually we have one class bank is abstract class, and we have two implementation of that class. We have two subclasses of that, SBI and PNB. So actually this show the multiple inheritance, and here we have abstract method get rate of interest, and we have two implementation of the abstract method. The only difference in this program is that we have created the abstract object through another method. We first declare and then we create an object. Abstract class having constructor and data members and methods. In this example we have an abstract class bike which having constructor as well as other data members and methods. So bike is one of the constructor, and here we give the implementation of the constructor inside the abstract class. System.out.println bike is created. We have abstract method abstract while. So abstract method will not have the implementation here. We will implement in one of the subclass. While change gear, this method is not abstract, so we have implemented here system.out.println gear change. So here we have one constructor bike, we have one abstract method run, and we have one another non-abstract method change gear. So they have three things: constructor, abstract method, and non-abstract method. So constructor have the implementation inside the abstract class The non-abstract method also have the implementation inside the abstract class, but the abstract method which we cannot implement inside the abstract class, we will implement the abstract method inside the subclass. So we have one subclass with the name Honda, which is a subclass of the parent class bike. So we extend bike through Honda, and we have the implementation of the run method, which is abstract method. The implementation is here, so it will show the message running safely. This is the implementation. We are going to print some message. Now we have another test class, test abstraction 2. If we want to save the program, we will use this name, test abstraction 2, because this class having the main method. And now we are going to create objects. So obj is the object of type bike, which is abstract class, and we are creating the instance of the object in the new Honda class, which is subclass. Through this object we are going to call the abstract method run, and we are going to call the non-abstract method. So whenever we create the object of Honda class, so the first of all the constructor is running and the constructor bike is created. First of all we will receive the constructor output, then we call the abstract method, so we will receive the implementation message of the abstract method running safely. And then we have called the non-abstract method, so we will receive the implementation message of the non-abstract method, which is gear change. Okay, now let's study some rule. If there is an abstract method in a class, that class must be abstract. If there is abstract method and you declare the class as non-abstract, then you will receive a compiler message. If you declare a method is in abstract, so you must also declare a class is in abstract. For example, we have a method run. The type of the method is the return type is nothing, but it is abstract method. So the class is non-abstract class. So if we compile this segment of code, we will receive a compiler message because the method is abstract and the class is non-abstract. So we must also make the class bike abstract. Second rule is that if you are extending an abstract class that has an abstract method, you must either provide the implementation of the method or make this class abstract. If you have some class, either you should provide the implementation or you must make the class abstract. If you are going to extend an abstract class which have abstract method, so you have two choices, either to provide the implementation of the method or make the class abstract. Either you make the method non-abstract and provide the implementation. In this slide now we are going to discuss another concept called interfaces in Java. So first of all we have to define what is interface. Interface in Java is a blueprint of a class. It is just a structure of a class. It has static, constant and abstract methods. So interface contains static, constant and abstract method. There can be only abstract methods in the Java interface, not method body. In the interface there will be only the body of the method, and that method must be abstract method, and there will be no implementation of the abstract method. Why we use interfaces in Java? It is used to achieve abstraction. and multiple inheritance in Java. Abstraction and interfaces are closely related to each other. So interface is one way to achieve multiple inheritance and abstraction. So abstraction is a concept and interface is the implementation of the abstraction. In other words, you can say that interfaces can have abstract method and variable. It cannot have a method body. They can only have the abstract method, just the definition of the method, and there will be no implementation of the method inside the interface. Java interface also represents the as-a relationship. It represents as-a relationship like inheritance. It also represents as-a relationship. It cannot be instantiated just like the abstract class. Similar to abstract class, we cannot create the instance of the interface. After Java 2, since Java 2, we can have default and static method in interface. And since Java 9, we can have private method in interface as well. So now the question is that why we use Java interfaces. So the first reason is it is used to achieve abstraction. The second reason to use interfaces in Java is by interface we can support the functionality of multiple inheritance. We can only implement multiple inheritance without ambiguity through interfaces. It can be used to achieve loose coupling. So what is the connection of this concept with software engineering? So the connection is that interfaces achieve loose coupling while inheritance achieve high coupling, strong coupling. How to declare an interface? An interface is declared by using the interface keyword. It provides total abstraction, means all the method in interface are. At the start of the lecture, we write how to implement abstraction. So there were two methods. The first one through abstraction and the second one through interfaces. So through abstraction we can implement abstraction from 0 to 100%. But through interfaces we can implement abstraction 100%. So it provides total abstraction, means all the method and interface are declared with the empty body and all the fields are public, static and final by default. So in interface all the method will be abstract method and all the fields will be the access type of the field will be public and it will be static and final by default. By default, if we not write the final, it will be final by default. A class that implements an interface must implement all the methods declared in the interface. If any class wants to implement some interface, so it must implement all the methods which is declared in that interface. Syntax is that we have interface, then we have angular brackets, and then we have the name of the interface, and then inside the curly braces we have the body of the interface. Inside the body we can have constant fields, we can have methods that are abstract, and we can have other things which by default will be final. Now let's study the relationship between classes and interfaces. So let's see the figure given below. So a class extend class here, and interface can extend interface. A class extend class, in interface extend interface. But here a class implements interface. So the relationship between a class and interface is that an interface can be implemented by a class. So we can say a class implements an interface. Let's see some example of the interface. For example, we have interface printable. The name of the interface is printable, and it is declared with the keyword interface. And this interface have method print. Now we have class A6 which implements printable, which implements that interface printable, and here we will use implements keyword instead of the extend keyword as we use in the classes. So we have another method print, and print having the implementation. So this interface having a method print, and here we have the implementation of the method, and the method showing message hello. So we have main method. In the main method we create an object of class A6. As usual, we create an object, and through this object we call the method print. So this interface have the print method which is implemented through the class A6. So the class actually implement the interface. The interface only have the blueprint, only the definition of the method, and the interface. Inside the interface we implement the method print. So this is the output of this simple program. Now let's see how multiple inheritance is implemented by interface. If a class implements multiple interfaces or an interface extends multiple interfaces, it is known as multiple inheritance. So we can implement multiple inheritance in Java through interfaces. So we have two interfaces which a single class is going to implement the two interfaces, and we can have two interfaces which is extended from a single interface. Multiple inheritance example in Java. Now let's see some example implementation of the previous diagram. So we have one interface printable, and we have one method, just the definition of the method print. We have another interface showable, and we have one method show, just the definition in the interface, and we have class A7 which implements both of the interfaces, printable and showable. In the implementation of the printable interface we have a method print, and the implementation of the method print we are going to show the message hello, while in the implementation of show message which belongs to showable interface we are going to print the message welcome. So we have the main method, and the main method we are declaring object obj. So we are creating object obj of class A7, and we are calling both of the method obj.print which will show hello, and obj.show which will show welcome on the screen. Now let's answer a simple question. As we have discussed in the previous inheritance topic that multiple inheritance is not supported through class in Java, but it is possible by an interface. So why multiple inheritance in Java is not possible through class? and why it is possible through interface. So the simple answer is that if we are going to achieve multiple inheritance through class, so there will be ambiguity. So because of the ambiguity, we will receive a compiler error. So we say multiple inheritance in Java through class is not allowed. We cannot achieve multiple inheritance through class in Java, but through interface we can achieve multiple inheritance because there will be no ambiguity if we are going to achieve multiple inheritance through interfaces. The reason is that the implementation of the interface is provided by the class, not by the interface itself. So the answer to question multiple inheritance is not supported through class in Java. So the answer is that multiple inheritance is not supported in the case of class because of ambiguity. And why it is possible through interface? So the answer is that it is supported in case of an interface because there is no ambiguity. So why there is no ambiguity? So the answer is that it is because its implementation is provided by implementation class. The interface not have any implementation. Its implementation is provided in the interface class. Multiple inheritance through interface. So let's see some example. We have interface printable, they have method print. We have interface showable, they have method print. Now we have class test interface 3 which implements both printable and showable. We have another method print. In this class test interface 3 we are going to implement the print method which is part of the printable interface as well as part of the showable interface. Now we have main method and we create object of test interface 3 and we call the method. So we will receive hello. So this is a simple example of multiple inheritance through interface. So we achieve multiple inheritance through interface without any ambiguity because here two interfaces have the same method, but these interfaces only have definition and the implementation is only one, so it will call the implementation. The message is the output is in the implementation, so there is no ambiguity and there will be no compiler error in case of interfaces. If we use classes printable and showable, then we will receive a compiler message because the implementation is also given in the class. But here the implementation is by the class, not by the interface itself. Interface inheritance. Now let's see the inheritance of the interface. One interface extends another interface. A class implements an interface, but one interface extends another interface. So we have printable interface, they have a method print, and we have showable interface which extend the printable interface and they have the message show. We have class test interface 4 which implement showable, which implement the sub interface. So now we have the implementation of the print method as well as the show method. As well we have the implementation of the printable method print, the parent interface, and we have the implementation of the sub interface showable, the method of the showable show. So we have both of the implementation in a single class. We have main method, we have created the object of test interface 4. The name of the object is obj and we call the print method and we call the show method. So we will receive hello and we will receive welcome. So this is the example previously we have discussed, but here this line implements interface inheritance. Here we have another question: what is marker or tag interface? So the answer is that an interface which have no member is known as marker or tag interface. For example, serializable, clonable or remote. These are the example of tag or marker interface. They just pass some information to the Java virtual machine. They are used. The marker or tag interface are used to provide some essential information to the Java virtual machine so that Java virtual machine may perform some useful operations like we use serializable, clonable or remote. So these are the advanced concepts which pre-serializable and deserializable we can also create object, and remote we will use in the remote method in the client server communication. So the marker or tag interface are that which have no member, and it only can pass some information to the Java virtual machine. This is an example of a marker or tag interface, and the name is serializable. Nested interface in Java, as the name implies, similar to nested loop. If we have one interface inside another interface, then this phenomena is called nested interfaces. For example, we have interface printable, we have method of the printable interface, and inside this interface body we have another interface called message printable, and they also have their own method message. So one interface is inside another interface, so it is called nested interface. As the last topic, we are going to discuss to differentiate between abstract class and interfaces. So abstract class can have abstract and non-abstract method, but interface can have only abstract method, and since Java 8 it can have default and static method also. The second difference is that abstract class doesn't support multiple inheritance, but interfaces support multiple inheritance. Abstract class can have final, non-final, static and non-static variable. Interface has only static and final variables. Abstract class can provide the implementation of interface. Interface cannot provide the implementation of abstract class. The abstract keyword is used to declare abstract class, while the interface keyword is used to declare interface. Abstract class can extend another Java class and implement multiple Java interfaces. An interface can extend another Java interface but cannot implement abstract class. An abstract class can be extended using keyword extend, but an interface can be implemented using keyword implements. In Java, abstract class can have class member like private, protected. Member of a Java interface are public by default. If we didn't use any access modifier, then it will be public by default. Okay, to summarize today's lecture, we have studied abstraction and we have studied interfaces. So today we have studied two methods how to implement abstraction. The first one was by abstract class, and the second method to implement abstraction was through interfaces. So I request all of you to run the program given here by yourself, And if you have any question related to some concepts which is related to the software construction course, then we will have a Zoom or a Tencent meeting, and then you prepare your question and then discuss with me in face-to-face meeting. So it's time to finish the lecture. Allah Hafiz.